Well, hello and welcome back. We've got another great video on graphs and roots of a polynomial. Now, you've heard of monomial and binomial. Today we're going to focus on polynomials. Monomial obviously meant one, binomial meant two, bi like bicycle, and poly just means many. Now, before we get started, I have to tell you, this is all on your calculator. All right, so don't waste your time tonight if you're not going to sit there with your calculator. So pause it, go get it, and play along with me. So, a polynomial function is a function consisting of terms that have whole number powers. In the most general form, a polynomial can be rewritten like this. And now, maybe that looks a little scary to you, so I can change it. I could say like 4x to the 5th plus 3x to the 4th plus 2x cubed plus 6x squared plus x plus 2. It's just a term with many terms in it. Quadratic and linear functions are the simplest of all polynomials. Today we're going to explore cubics and quartics, those whose highest powers are x cubed and x to the 4th respectively. Example 1. For each of the following cubic functions, sketch the graph and circle the x-intercepts. So I literally just want you to go to your calculator, type this function in, and we're going to sketch it. Now the one thing you'll have to notice is your window. I gave you the window to use. So notice this is your x min. Okay, so obviously hit your window. This is your x max. This is your y max and your y min. All right, the window was given to you. So I have a root at 1, a root at 4, and a root at -2. And hopefully your graph looks like mine. Let's see, I also had a y-intercept up at 8. And my graph should look like this. Okay. And it says sketch and circle its x-intercepts. So I want to be very clear that these are your x-intercepts. Okay, now those names, okay, they have lots of names that mean the same thing. One was x-intercept. Let's get these in our notebook. They are also called roots, and they are also called zeros. All right, your exam may refer to them in any one of these three ways, but they all mean the same thing. Now let me throw another question at you. When if I asked you what is the sum of your roots? All you would do is take your three roots, -2, 1, and 4, and add them together. So I would say the sum of my roots is 3. When if I asked for the product of my roots? Okay, again, I would just take those roots, and this time, instead of adding them, I would multiply them. And I would get -8. So be very careful. Watch the question. Sometimes they just want you to list them out. Sometimes they want you to do something with them. Example 2. We got another nice cubic. So we're just going to our calculator and typing that function in. Again, take note they gave you a window, so you'll have to change your window to match theirs. So you should be playing along. Let's see, I had an x-intercept of maybe, it was a little odd, it was like -2 point something, and it only hit once. It looked like it came close, but it didn't actually touch again. And let's stick arrows on the end showing it goes on forever. So I'd say I only have one x-intercept. On my last graph, again, I've got it typed in nice and neat. I have an intercept at 0, and I have an intercept at 3. Okay, and my function goes up. It looks like it comes back down, touches 3, and goes back up. So again, it just wants to clearly identify the roots, the 0, or the x-intercept. Remember, those all mean the same thing. So the whole point of this was discovering how many options you could have. A cubic, an x-cubed term, could have a total of 3 roots. It could just have 1 root, or it could have 2 roots. Exercise 2. Consider the cubic, and again, it's called a cubic because its highest exponent is a 3, whose equation is given there. Algebraically determine the zeros. So when I want to determine the zeros, I basically just set my equation equal to 0. So 0 equals x cubed minus x squared minus 12x. Now, I want to be very clear. Okay, and this is a huge deal. Some people are going to miss this every year. And I want to be clear, the quadratic formula can only be used for quadratics. Okay, that means it has an highest exponent of x squared. Is this a quadratic? Well, we said no. It's called a cubic okay, because its highest exponent is a cube. So the quadratic formula is completely out of the question. You can only use that on quadratic equations. That means you should know how to do this. Well, I'm just going to go back to the basics and pull out a GCF of x. So I've got x squared minus x minus 12. Okay, now remember, bring that x down for the right in front, and this should factor very nicely. X minus 4 and x plus 3. So when I tee it up, I've got like 3 t's here, or 2 t's I could say. I'm going to say let x equal 0, let x minus 4 equal 0, and let x plus 3 equal 0. So I get 3 answers. The first one is x equals 0, the next one is x equals 4, and the next one is x equals negative 3. Now that I know my roots, it says sketch a graph of this function using your answer from part A. So it says doesn't pick up the calculator. Use your roots and plot them. So I have one at 0, one at 4, 1, 2, 3, 4, and one at negative 3. Okay. Now we just saw from our previous examples that the cubic starts low and it's got to go up and it's got to hit all these roots and go back. So I know it's going to go something like this. I got to go through all those roots or zeros. So I just want to be clear, those 3 numbers there are called roots, zeros, and x-intercepts. All mean the same thing. Exercise 3. The largest root of x cubed minus 9x squared plus 12x plus 22 falls between what 2 consecutive integers? All right, so let's take a look at that function. All right, notice it said it wants the root, so I'm setting my equation equal to 0. Now I can't pull out a GCF. Does every single term have an x? No. So all I'm going to do is graph this thing. So let's go to your calculator. Let's get this in y equals. And let's just start, of course, on zoom 6. We'll set that to our standard 10 by 10 window. So I've typed it in and I've hit zoom 6 and I can see part of my graph. Clearly I know that it's a cubic, so I know it's got to go up, come back down, and go back up. So I know I need to fix my, that's my y max, because I want to go up, and I want to go down, so I want to fix my y min. So I'm just going to play with my calculator. I'm not going to go crazy. Don't type in like 500. Just change it a little so you can see the whole graph. So I've changed my y min and max so it fits in there nicely, and hopefully you've done the same. Now we can answer the question. It says the largest root falls between what 2 consecutive numbers? Well, I think you can clearly see that you have 3 roots, and it says the largest, so I'm going to zoom in on this root right here. And it says that falls between what 2 numbers? Well, basically, I just need to get my 0 on my calculator, so we use second trace intersection, and we can go get that 0, and figure out what it falls between. So remember, you're going second trace, and you're picking 0, and I want to see what that falls between. On my calculator, when I did that, I got 6.732. So make sure you're doing it, and if you have questions, come in the morning and ask them if you can't get that on your own. So I would say that that number falls between 6 and 7. Exercise 4, consider the quartic function. Now this one's called quartic because its highest exponent is x to the 4th. Algebraically determine the x-intercepts. All right, so if I want an x-intercept, I know my y value is equal to 0. Now, is there a GCF to pull out? Okay, you might be thinking yes, but clearly this term doesn't have a x, so there's no GCF. That means I just have to be able to factor this bad boy. Now, what multiplies to x to the 4th would be x squared and x squared. So instead of x and x, I'm just using x squared and x squared. 4, my only options are 4 and 1. Remember, it's MAM, multiply, add, multiply. And if I'm multiplying to a positive, that means the signs are the same. And if I'm adding to a negative, that means they're both negative. Now look how exciting this one is. This one's not done being factored. It's not factored completely. What's special about x squared minus 1? Well, that can factor to x plus 1 and x minus 1. What's special about x squared minus 4? That can factor to x plus 2 and x minus 2. So when I tee it up, I've got to tee it up here, here, and here. I actually get 4 solutions. X equals negative 1, x equals positive 1, x equals negative 2, and x equals positive 2. So you'll notice if your exponent says 4, you should be getting 4 solutions. If you look at our previous example, when it was x cubed, we got 3 solutions. So let's just go ahead and plot these. I have one at -1 and +1, one at -2, and one at +2. Now, you haven't seen anything like this before, so feel free to get that in your calculator. So I'm typing in x to the 4th minus 5x squared plus 4. And I'm going to go back and, you can use your Zoom 6, but they do give you this nice window to use here. And let's graph that function. And it looks like I have a y-intercept of 4. So my graph is going to look like this. Okay? But notice when you have x to the 4th, you should have 4 x-intercepts, or 4 roots. Exercise 5. Consider this quartic equation that's given there. Now remember, x to the 4th tells me quartic. Sketch a graph of this quartic on the x-axis and label its x-intercepts. Now, look at my crazy window. Okay? You're going to have to change your window, and from -10 to +10, but look at my y-min and max. -500 to +500. So grab that calculator, slow down, and let's get that in there. So I've got my roots labeled. I went and found each of them, and my graph should look like this. Now part B says, based on your graph from part A, write this expression in factored form. So just looking at this graph, you should be able to figure out how this gets factored. Well, let's work backwards. If one root is x equals -7, okay, I'm going to work backwards from my t basically. X equals -2, x equals 1, and x equals 5. All right, I'm working backwards. To get x equals -7, I would have had to have x plus 7 equals 0, x plus 2 equals 0, x minus 1 equals 0, and x minus 5 equals 0. Okay, so I'm basically just working backwards, which tells me that this factored version is x plus 7 times x plus 2 times x minus 1 times x minus 5. And that's how that function would get factored up here. Okay, so again, I just worked backwards. I said this is what it's equal to, so this is where it came from. If it's equal to -2, I added it over to get it equal to 0. Therefore, those are all my factors. Well, that does it for us tonight. We'll get a lot more practice on the calculator tomorrow. Have a great night.